Next topic in this chapter, we're going to talk about mirrors. So the first one is concave mirror. Concave mirror is nothing but where edges curve towards the light source. So here is a simple example. Assume that here is a light source. So light source need not to be which produces light. Say for example, if you stand there, the sunlight is going to fall on you and you're going to emit the light rays. Okay, so the edges of the mirror bend towards the light source. That mirror is called concave mirror. Now for the concave mirror, whenever light rays fall onto the mirror, all the light rays are going to focus at one point. That point is called focal point. Okay, focal point. That focal point I'm representing with capital F right here, capital F. Now the length from focal point to the center of the mirror, we call that as focal length. So from here to focal point to center of the mirror, that's a focal length. I'm representing with the small f. R is the radius of curvature. Okay, so for a perfect focused mirror, f is the small f. Focal length is always equal to r by 2. Focal length is always radius of curvature over 2 for a perfect mirror. Now here is the mirror equation. Say for example, an object is standing in front of the mirror. So here is the mirror, here is the focal point represented f. D naught is distance of the object, di is the distance of the image, h naught height of the object, hi is the height of the image. Okay, so the mirror equation is nothing but 1 over d naught plus 1 over di equal to 1 over f. Okay. Remember here everything is in front of the mirror, so basically your eye is somewhere here. Okay, we're looking from there, so the light rays are coming into your eye from there, basically from the mirror. So everything, distance of the object is in front of the mirror, distance of the image is in front of the mirror, focal point is also in front of the mirror. Now the magnification is nothing but how big or how small is the image, is defined as m equal to hi over h naught, height of the image over height of the object, or minus distance of the image over distance of the object. Say if I have this magnification factor as a negative number, that indicates that image is inverted. So here in this case you saw the image is inverted. Okay, if I have this magnification factor positive, that means image is upright. Okay, now when it comes to the convex mirror, mirror edges curve away from the light source. So basically here is your eye, we're looking at the mirror. Okay, it's a convex mirror, so the light rays are going to come into your eye from the mirror. So mirror edges curve away from the light source. So basically source is right here, so sunlight is falling on this object or this person, and they're scattered all around. Okay, so for this convex mirror, the focal point is going to be behind the mirror. Okay, focal point is behind the mirror, so all the light rays fall in onto this, they're going to scatter or go in different directions. But when we draw further towards the focal point, then we can find the focal length. Now the focal length 1 over d naught plus 1 over di equal to minus 1 over f. For the convex mirror, f equal to behind the mirror, so take that as a negative. Here the focal point is in front of the mirror, so I took that as positive f. Here it is behind the mirror, so it's going to take that as negative. Magnification factor same, m equal to hi over h naught or minus di over d naught. So here also if we end up with a negative number, it is going to be inverted. Now here is a simple example. A 1.5 centimeter high object is placed 20 centimeter from a concave mirror with radius of curvature 30 centimeter. Determine the position of the image and its size. find the above same if we move the object to 10 centimeter. So there are two questions. So let me look into the first one. A 1.5 centimeter high object is placed 20 centimeters from a concave mirror. He clearly mentioned it's a concave, so I draw the concave mirror. And focal length, he didn't give the focal length, but he gave you curvature of radius of curvature. So from there I'm assuming it is a it has a perfect focus. Okay, so that's what you can see for a perfect focus, f equal to r by 2. So I'm assuming it has a perfect focus. From there I found the focal length, f equal to r by 2, which is 15 centimeter. Now object is placed 20 centimeter in front of the mirror. So by using mirror equation, 1 over d naught plus 1 over d equal to 1 over f. So 1 over d equal to 1 over 15 minus 1 over 20 will end up with 1 over 60. So distance of image is 60 centimeters. Now the magnification factor m equal to minus di by d naught. So minus 60 over 20, which is minus 3. So the image is going to appear 3 times larger than the object. So I mean, you can clearly see m equal to height of the image over height of the object, okay, which is 3, negative 3. So height of the image is nothing but negative 3 times 1.5, which is given negative 4.5 centimeter. Okay, so this height of the object is going to be 4.5 centimeter, which is three times bigger than the real object. Now that m indicates, m is a negative number, so basically that is nothing but the image is going to be inverted. By the way, the di, I end up with a positive number. Okay, since it's a positive number, it is going to be in front of the mirror. Now in part B, find the above same if we move the object to 10 centimeter. So in the second case, what we did here, we moved the object. So distance of the object is 10 centimeter and focal length is 15 centimeter. So 1 over di plus 1 over d naught equal to 1 over f, which is 1 over 15. So distance of the image is 1 over 15 minus 1 over 10. I end up with see di is negative 30 centimeters. So that negative indicates that object is, or image is, the other side of the mirror. So this, because of this negative 30 centimeter, because of that negative number, I have my image is inside the mirror. Okay, it's right here, 30 centimeter. Now magnification factor minus di by d naught minus of minus 30 over 10. So magnification factor is 3. So magnification factor is a positive number, so we'll end up with upright image. Okay, this image is called virtual image. It's not a real image. Okay, whenever you see an image upright, not inverted, if it is not inverted and it's upright, then that image we call it as virtual image. Okay, virtual image is nothing but we think that the object is right there at the virtual point, but in reality the object is somewhere else. Okay, that's the reason we call it as virtual. Okay, and the height of the image is nothing but 3 times 1.5, 4.5 centimeter. Okay, so if I place at a different point the object, the the size of the image is going to change, as well as sometimes it's going to be inverted, sometimes it's not going to be inverted. Now I'm going to solve one more example here. Here is the next example. A mirror at an amusement park shows an upright image of any person who stands in front of it. Actually he gave you the stance, who stands 1.7 meters in front of it. I forgot to write that. He gave you that information. Okay, so distance of the object is given, who stands 1.7 meters in front of it. The image is 3 times the person's height. What is the radius of curvature? And now in amusement parks, what kind of mirrors do we see? Is it a concave mirror or convex mirror? So basically, if you go to the Walmart, probably the mirrors hanging on the ceiling look like this. Is it concave or convex? So you're standing right down there. So when you look at the mirror, edges are away from the object. So basically, it is a convex mirror. Okay. So I'm going to write down or draw the diagram here. So here is an object. The distance of the object is 1.7 meter. Okay, and shows the image as of a person who stands in front of it. The image is 3 times the person's height. What is the radius of the curvature? He also mentioned upright image. Okay, so basically the image is not inverted. So m equal to distance of the image over distance of the object. Okay, and it's upright image, so I mean it's minus basically. Can I say that value is 3? So can I say minus distance of the image must be 3 times distance of the object? So 3 times 1.7 will end up with 5.1 meter. So the distance of the image is negative 5.1 meter. Now the radius of curvature, so it's a concave, sorry, it's a convex mirror, so f is going to be somewhere here. Okay, so 1 over distance of image or distance of object plus, so here for the convex mirror, 1 over d naught plus 1 over di equal to minus 1 over f. So I know d naught, which is distance of the object, 1 over 1.7. Distance of image is 1 over 5.1 equal to minus 1 over f. So once I found the f value equal to minus 2.55 meters. So basically I have negative number. That negative indicates that focal length is behind the mirror, and the radius of curvature is, I mean, he's talking about radius of curvature. I didn't take negative because basically this is the radius of curvature, or he's just asking for the number. Okay, or equal to 5.1 meters. I will stop it here. I'll continue with another video solving more examples based on this mirrors. Thank you.